Welcome to the Meat and Potatoes podcast. We're here with Brad Plothow, who is the Chief Growth Officer at Intergalactic. How are you?
Good. How are you?
I am very good, and I'm excited about this one. Intergalactic, that implies some things, but we're going to talk about like Mach speeds and space and awesome stuff. And this is like a company in St. George.
That's right.
What is Intergalactic? Let's just start with the fun, soft, easy one.
Sure. First of all, it's a song by the Beastie Boys. That's intentional. We did go through a process to try to figure out what we were going to call the company. We rebranded it about 2 years ago. And part of that was there's this kind of 80s and 90s pop culture vibe. That's when a lot of the pop culture reflected the cool stuff that we wanted to do, like flying cars or, a lot of deep space exploration. And it was in pop culture, but it wasn't happening in real life. And so we want to get back to that. There's this like need to innovate in air and space. And so Intergalactic was kind of like an homage to all that stuff that we grew up with as kids. But we're an aerospace thermal management systems integrator. And that is like a little technical, but basically, if you think about what happens in air and space, you've got these big platform companies like SpaceX or like Boeing or Lockheed Martin, and they're the airframer. They make the rocket, they make the jet, right? And underneath them, there's a whole value chain of companies that are building things that they need. And one of the constraining problems that you have in air and space is that things get really too hot, too cold. You got to regulate the temperature of the crew, of the computing systems, the mechanical systems. Everything needs to have its temperature regulated. And the more innovation that gets baked into those platforms, the more there is a need to regulate that temperature. And so we're building new technologies and new systems that regulate the thermal challenges on those platforms. So that's what we do.
All right. It's going to be a lot of science, which I don't think either one of us are scientists.
I'm a marketing guy, so yeah, we'll do our best.
But a lot of this is fairly common sense, right? You could even boil it down to, for us in America, we're kind of soft with like air conditioning, right?
Right.
You turn the temperature up to 73 and there's going to be a riot. You turn it down to 64, there's going to be a riot. Everyone's going to survive, but you do that in space or with like rockets, things can go bad if temperatures aren't correct.
Yeah. Well, first of all, you mentioned air conditioning, and we take it for granted now, but there's like good science that when temperature extremes start to set in, like human behavior changes.
Mm-hmm.
So you obviously don't want that when you're piloting an aircraft, especially if it's like, you're in a dogfight in an F-35 or something, right?
Yeah.
And you also don't want that if you're on a space crew. And, obviously, if you're on a long flight, you've got to be comfortable. But beyond that, when your computer starts to heat up and all the electronics that are going on behind the scenes are like really working overdrive, the fan turns on.
Yep.
And that's meant to cool the components that are required to make the computer work. Same thing's happening on all these advanced computing systems that are on space platforms, on airborne platforms, and nobody sees that. We don't see any of that that's going on. In fact, there was a company, one of the things that's happening in the commercial aviation space is that if you remember the Blackbird, this is a supersonic plane that was kind of more like a technology demonstrator, didn't ever really get legs. But there are companies that are trying to bring that back and commercially validate it. That you could, send people from Salt Lake to Paris in like 3 or 4 hours. And they had this little tiny sensor, one company that was building one of these planes on top of the plane meant to communicate with satellites or with other, comms devices. And it's like, well, we can't cool that thing down. The space that we need is too small. And that's kind of what we do is we build thermal systems that can fit into small spaces because you have heat loads that are getting larger, but all the components have to shrink and everything has to get smaller and lighter. So thermal problems are everywhere and we just don't see them.
Yeah. And if they don't work, again, being selfish as humans, like you're going to get hot or cold. But, if you're flying from LA to New York and the temperature is perfect, that means that there's machines that are making it that way, and they also get hot and cold.
Yeah.
And so outside of like giant air conditioners and swamp coolers, which aren't applicable, you got to make things smaller, better. And I assume that it is materials, a lot of engineering, a lot of R&D. So where are you guys focused in particular right now?
So the initial innovation for our company, the company was founded actually by some engineers who came out of a large like aerospace OEM. There's all these companies and they're so like old school. A lot of them are on the coast, and they've been doing this for years. They've been manufacturing parts or like developing systems, and they're all public companies. They grow through acquisition of smaller supply chain companies, and it can be a hard place to work if you're an engineer who's trying to innovate. And a couple of engineers said, "Hey, there's this platform with a tier one defense contractor, one of the household names that you could imagine, right? There's only a few of them, and they said they are looking for a pod thermal management system that fits in a pod that hangs under the wing of an aircraft. If you've seen Top Gun Maverick, you know that they fly over this hill and then they have to drop down, and then the pod targets, and then they drop in the missile and then they fly out, right? So that pod is packing a ton of computing power, needs to reject that heat. They needed to be able to fit something into that space, or they were going to lose that business. And so they're like, well, we have to build a heat exchanger at the core of that system that's totally new. And so Formula One racing has this concept called microtube heat exchangers. So they take these like long, stainless steel syringes. Basically, they microtubes, and they're like the diameter of the wall is like a fraction of the size of a human hair, and they weld those things together with end plates, and that rejects a ton of heat, and that becomes the heart of a system. And they're like, well, we want to build this and commercialize it. And their company said, no, like, we can't do that. We got to manage the quarters here. So they left. They started a company based on that heat exchanger technology, and they started to commercialize it and figure out how to make it work. And then they won that program with that defense prime, but they didn't know how to build a business. So then that was the company was started in Port Angeles, Washington. And then my friend from high school, Brian McCann, who was working for his family's aerospace company, came in and said, hey, we want to invest in this company. And then they realized, you need some help to build the business. You know how to do the technology. You don't have to like run the business. So they acquired it, moved it to St. George. And so that was our initial innovation, was microtube heat exchangers. And then we've built systems around that. And there's all kinds of other components. There's compressors, there's pumps, all kinds of things that you need to regulate heat. There are cold plates. There's all kinds of stuff. And so we do think about materials, we think about underlying technologies, and then we think about product design. And all three of those things are part of our roadmap.
Very cool. And it's not for the faint of heart, right? You've already mentioned a lot of things: science, engineering, defense contractors, probably layers and layers of bureaucracy.
Mm-hmm.
There has to be exacting standards, right? Has to work.
That's right.
If it doesn't, you'll probably be out of business.
That's right.
Reputation's important. And where are you guys focused as far as like your part of that supply chain? Do you work with the defense contractors?
Mm-hmm.
Do you guys innovate and then push it up? Do you wait for things to come to you? How does it work?
Yeah, really good question. So I came to Intergalactic and the aerospace world from the world of software, venture-backed software companies. So that like is very simple to me. Like, you got a concept, you get your kind of angel investment to get off the ground, Series A to launch, and then you start to scale with additional investment, and then eventually the company exits. Like, it's pretty it's like hitting balls down the middle of the fairway now. Very different in air and space, because you have a concept, and then you have to build it, and then you have to test and qualify it. And so testing and qualifying are required by the federal government, and also whether you're on a military platform or you're on a commercial platform. So the FAA or the military are going to make sure that you've gone through. And for example, with our systems, we have a full qualification that's required when we work with the defense prime. So our customers are companies like Lockheed Martin, Raytheon, Northrop Grumman. They're the prime. They're the ones who are building the platform. And then they come to key suppliers and say, okay, here's a key system. So we're a tier 2 system integrator. And so for thermal systems, we develop the entire system. And they come to us and say, here's our requirements. Here's what we want you to build. So that's one way that we get business, is that they come to us, they hand us, our engineers, a spec, and we build to that spec. The other way that we do it is that we intuit like some of the things that are happening in the market, and then we try to proactively, on our own internal research and development dime, develop a system that we think makes sense in products. So we have launched some products that are like totally on speculation, and then we bring like the Silicon Valley go-to-market rhythm to that, and we say, okay, let's generate demand against that product. So, for example, there's a whole world around what's called eVTOL. These are like flying taxis, and this is going to be a thing in this decade. People are, instead of taking an Uber everywhere, they're going to like get in a giant drone. They're going to fly over traffic, and those things are electric, and they have to have the batteries cooled. So we're working on products that cool not only the battery packs, but the crew and the passengers inside of there, right? So we do both of those things, and it does get very complicated because you have to qualify and test. And like one example is you have to shake your system to the point of like it falling apart, make sure that it falls apart at the right time. And so we've gone through all that stuff. We have fully qualified products now, but you have to beat the tar out of those things to make
Yeah.
sure of it.
And I'll oversimplify this, but it's probably fairly true, right? Like Uncle Sam is at the top of the
Right.
supply chain. And Uncle Sam says, we want a spaceship that can launch from Provo and then fly up to the moon and drop off mail,
Hmm.
right? Um, they have that if it's like we need to drop mail off in Denver, but there's heat transfers when you leave the solar system and you come back in, right? And I'm using kind of an example that will happen at some point in our lives. And then they'll say, who wants it? Oh, Boeing. Like there's some sort of bidding thing.
Hmm.
And then at that point, they're on the hook to Uncle Sam. And that makes everybody else underneath them on the hook as well. And you guys would be an integral part of that because of the heat transfer of flying from Provo to the moon.
That's right. So using that example here, like taking even like a little bit further. So you're gonna have to have a rocket that gets the payload off the Earth.
Yep.
That rocket, like SpaceX, their rockets have like dozens of places where they need very advanced heat exchangers just on the stage one rocket, right? And then you're talking about all the other places where you have to have fully integrated thermal management systems for keeping the crew comfortable and alive, keeping all the electronics working, mechanical systems working. So there's just a zillion places where you have thermal problems. And then once you get into space, you have a whole new set of problems because you have hot side, cold side as you're like, you know, moving through space. So like if you're a small satellite and it's like turning, you've got a hot side, cold side, depending on which side is facing the sun. So you actually have to also worry about if things get too cold, then you get to the moon. So we're going to have permanent bases on the moon and in orbit around the moon soon. And there's a whole bunch of problems there too. So if you've seen or read The Martian, like that rover saved Mark Watney's life, not just because it provided breathable air, but because it helped him regulate like these massive temperature extremes. And on Mars, again, it's fiction, but it's based in some truth. On Mars, you don't have nearly the temperature extremes that you might have on the moon because there's no atmosphere. So imagine like 700-800 degree temperature swings. When you have permanent crew and who are stationed on the moon, when they leave the base, those rovers have to have the capability to keep them warm and cool them off, in addition to managing all the thermal challenges of the craft itself. So those are things that we're actively working on. And then, you know, the base that will float around and be in orbit around the moon is going to have like a very advanced habitation system, the airlocks, how you keep people safe. All those things have thermal challenges and pressure challenges, and that's another place where we play.
Oh yeah, we could we could talk for 30 hours
Yeah,
about this. Well, we couldn't.
the
Uh,
engineers could.
the engineers could, but they've dedicated like their entire lives and courses of study. And I think as far as like problem solving, if you're like an engineer that likes solving problems, it doesn't get any better
Yeah, yeah.
than what you just described. And then there's 50,000 other things to factor in, right?
And it's cool because, you know, in Utah, I've been used to working with software engineers and really intelligent people. We have software engineers that work for us too because we have software and hardware. But now I'm also working with mechanical engineers, design engineers, thermal systems engineers, people who are looking at thermal fluids and those kinds of things. So it's a whole different world.
Yeah. It's very, very cool. And let's talk a few like things that I found on your website. We'll hit on a few because I think there's cool stories behind them.
Yep.
AS 9100 certified.
Yeah. So again, if you're going to do business with the government, even if you're downstream from the government's actual customer, which might be like Raytheon or Lockheed Martin, you have to be compliant with all these different things. So how do you run your business? Do you protect confidential information? Do you like put tools away the right way? All that stuff is audited, and so we go through an audit every year. We actually just finished it and just passed the audit. So that's a credit to our team, but that's part of the deal. And so you have to renew these certifications, and there's a bunch of them. And AS 9100 is kind of like the standard, just to make sure that you're like competent enough to do business in the aerospace world. And so that's true not only if you're going to be working on defense programs. So we really are working like three arenas. There's military aerospace, so that's defense programs that are literally tied to the DoD budget. There's civil aviation, so that's regulated by the FAA, and then there's space. And a lot of the space stuff, even SpaceX, is getting a lot of its money from NASA, so it still has ties to government dollars. And no matter what you're doing, you got to be AS 9100 certified.
Yeah. Um, so do the people come to your R&D facility and check?
Yeah, they
Or
get
white
all
glove?
up in our shorts for a week. So
Interesting.
and so they'll check everything from like in my case, like, hey, when you put a post on LinkedIn, um, what are somebody checking that to make sure there's no like confidential information? And so we have a process there, and we have to document literally every time I post something on LinkedIn or when I post a new page to our website. That's got to have gone through like a check with somebody who's got the ability to say, yeah, I sign off on this, and we have to document it. And then obviously you get into things like, well, are you covering things when people are visiting your shop that are confidential? And so, yeah, we have to do all that. And then literally, are you putting tools away the right way? How are you dealing with fluids? Because we use a lot of fluids in the things that we build. How do you dispose of them? So it's how do you run the business, and how do you handle like the actual mechanical stuff when you're manufacturing and assembling the systems, everything.
Yeah. Well, what a cool world you guys are living in. By the way, this is in St. George, Utah.
That's right. Yeah.
It's on Tech Ridge, right?
So we will be. So there's taken a while to build right now. So that's been a challenge for us. Right now, we're actually in the same facility as RAM Aviation, Space and Defense. So they're our majority owner. They're a 50-year-old manufacturer of actuated parts like solenoids and valves for aerospace. And so they've built content that goes on like the Crew Dragon. So if you see like the Crew Dragon like shooting like air pockets out to like maneuver, that's valves that were manufactured by RAM. And so we co-house with them right now. But yeah, our plans are to move on to Tech Ridge, which is this big tech development on the top of a mesa where the old airport used to be in St. George.
Yeah. It's going to be very cool.
Yeah.
And if I remember right, like the Apollo mission had like 400,000 subcontractors, right? For these, whether it's NASA or Boeing or SpaceX, do you have any idea? It's fine if you don't, of like how many subcontractors filter up?
I mean, that's probably in the ballpark, give or take. And it's interesting you mentioned that because like when the Apollo program was getting up and going, the context for that was that JFK at the beginning of the decade says, "Hey, we're going to go to the moon," at like some random speech at a university, right? And everyone's freaking out. But the reason that he was doing that wasn't just like for political purposes. There was like demonstrating that the United States of America could get to the moon first was really important as a technology demonstration against Russia. The Cold War is the context for all this stuff, right? So you come out of World War II, there's a power vacuum, vacuums get filled, who's going to fill it? The United States and Russia were really like angling there, and it became an arms race, and it became about air and space, and also like naval power, right? But in terms of air and space, the capabilities, demonstrating the capabilities to get to the moon had a lot of other implications. Like we can do all kinds of other things, right? Including nuclear capabilities. So that is what created like that urgency to innovate, created that supply chain. And that's why you have hundreds of companies that are contributing to that effort because they all are feeling like the benefits and the urgency around that effort. And that has not been true for 50 years. Once we haven't sent anybody to the moon for 50 years.
Yep.
So in our lifetimes, there hasn't been a Neil Armstrong moment. Now there is tons of innovation pressure again. And that's because China has sent a hypersonic missile around the world. And there's reports that Russia has done the same thing locally in Ukraine. And so they have capabilities that may be on par or better than ours now. And so they're like, okay, we got to move. Plus, supply chain challenges. Most of our raw materials for a lot of things, including microchips, come out of China. Obviously, there's challenges there now. And so where else can you find those raw materials? You can find them on the moon. Yeah. But you got to get there first. You got to lay claim and put flags down. So there's tons and tons of companies that have been like built during that legacy period that have just been like kind of incrementally innovating over the last 50 years. But you're going to see hundreds of companies pop up like us that recognize that there's like a new urgency in air and space.
Yeah, it is quite the industry. And whether you dislike the military-industrial complex for whatever reasons. Um, it's in one form or another benefited pretty much everyone
Hmm.
on planet Earth, right?
Hmm.
With what you guys are discovering and the countless others, there's plenty of applications for a normal run-of-mill person, right?
Yeah.
Let
Yeah.
alone like that they're the GPS works and the air conditioning works on the plane and all of that, right?
Yep.
Because it again, heat transfer and that's kind of your guys' bread and butter just doesn't happen magically. There's a lot of work
Yeah.
that goes into it.
Yeah.
One more. Let's talk about 27 G's of force.
So these are all claims on our website that come from the testing that we do. So again, you build something um, basically as a computer model first. Then you actually build it physically. You assemble it, and then you have to test it, and then you have to qualify it. And so there's a battery of tests that we send everything through, especially when we're qualifying for a major franchise program, which we've done with many programs now. So you have to like heat it up really to extreme temperatures. You have to put in a wind tunnel, all these kinds of things. So when you put in the wind tunnel, then you're putting G's of force on that system. And so that's where we have actually tested this at 27 G's of force, which is an insane amount of force. There's also, I think, 14,000 psi, which is like a proxy for pressure, right? And so you get a ton of pressure when you're taking things into high altitudes or into space. In this case, you can simulate that by going deep in the ocean. So we put a heat exchanger built out of Inconel, which is a super alloy that you use in space, and we put it on a deep sea submersible that one of these major primes had created for the purpose of validating technology, and dropped it to the bottom of the Mariana Trench in the ocean, deepest point in the ocean, and you get 14,000 psi of pressure, and that usually makes things break apart. And so the great news there was that there were no leaks on that heat exchanger. It held up very, very well. So yeah, we're definitely trying to build things that are super robust, because if you're going to go deeper into space, if you're going to go faster, if you're going to go, try to break boundaries, if you're going to send up people in a flying drone, everything has to go through its paces, make sure that's very, very safe.
Yeah, which is cool for the regulators to actually care about people,
Yeah.
right? Because there was a time where it was just a bunch of cowboys
Yeah.
experimenting with no parachutes, right?
Yeah.
And there's a lot of dead people to prove it. And those days are gone, obviously.
Right.
Everything's very regulated. But um, on your team, I imagine there's some really awesome folks, whether it's like scientists or engineers,
Hmm.
computer folks. Um, do you know who's like the biggest space expert on the team?
Well, that would be our head of space systems, Ben Bryan. So we actually recruited him out of Lockheed Space, and he's worked on a whole bunch of programs. So he was like a team lead on Orion. He actually helped build the heat shield for Orion. So and then Osiris Rex. So and he knows pretty much everybody at Lockheed Space. And so the work that he's done, he's also like a materials guy. So composite materials, that's really the place where we start when you're getting into space, because you can't use a lot of the same materials that we would use in airborne applications, because obviously it's got to be lighter, or the tolerances for temperature are very, very different. So he's our resident space cowboy. He's from Alaska, lives in Wyoming now, and he's the most interesting man in the world. One of these days, we'll have to get you to meet him.
I'd love to because I have a question that nobody's ever been able to answer. Right, you're watching any sci-fi movie. We could just say it's Star Wars, right? They clearly land on a planet.
Hmm.
They're not wearing respirators or anything. It's just a normal planet where everyone's breathing, and let's say it's the equivalent of an F-16, right?
Hmm.
And they get up and they fly off into space,
Right.
right? Um, Possibly theoretically in the future that would be feasible, but like eighth grade science would tell you, like, no, there's a big difference between flying around on a planet and then going up into space. And I'm sure he could theoretically answer a lot of those things,
Yeah. And
which
it's
would be fun.
and there's a ton of math. Obviously,
Yeah,
it's way beyond me. They didn't hire me to do math for
yeah,
sure, but like one example of that is the Curiosity helicopter, the little tiny helicopter they put on the moon. One of the challenges that they have is that the air density and the atmospheric density is very different than it is on Earth. So we know what it takes to get lift with a helicopter on planet Earth. It's completely different on planet Mars. And so if you watch like Interstellar, they're like evaluating every planet that they're considering going to, and they're looking at atmospheric density, what the kind of like ratio different kind of gases are, all that kind of stuff. That's a little more realistic because you would have a completely different situation depending on which planet you're on.
Yeah. It gets real complex
That's right.
real quick.
Yeah.
Um, let's talk a little bit about being the chief growth officer of a company like this.
Mhm.
Um, what's kind of a snapshot of your day, of your week? Where do you focus on? Where do you drive value?
Yeah. So, I'm used to the world of software, enterprise software, vertical SaaS, and there's a pretty well beaten playbook and well beaten path there. You basically figure out how to run a digital marketing funnel, right? And so I was a little leery that was going to translate into aerospace. It's all very much like guys meeting at conferences and like trading business cards and stuff. And there's a big BD element. So we do BD. So we have a BD pillar of what we're doing. And so we'll go to the Paris Air Show this year, and we'll exhibit, and we'll make contacts that way. We'll do outbound business development. That has to happen. This is a very like formal industry still in some ways, but there actually hasn't been much innovation on the business side with companies. Like if you look at the websites of most of these companies, not SpaceX, that's the exception. It looks like it came right out of 1998. Their product catalogs like download PDF. It's just like really old school. And
Mhm.
so really basic things like learning how to like do SEO for a company like this is actually fairly easy. So I do a lot of work on the marketing side personally with things like trying to build our digital marketing funnel, and it works pretty well. So a lot of the things that I learned working with growth stage software companies translate pretty well.
Yeah. And how many products do you guys have right now?
So we have 5 branded systems.
Okay.
That doesn't include a lot of the work that we're doing behind the scenes on like custom design work that's like maybe kind of not it's proprietary. So there's a ton of work that's not on the website. And then we've got about a dozen what are called subsystems. This would be like a heat exchanger or a pump. These are sometimes people just need those components, right? And so, but we're launching products all the time. We'll launch some new systems and some new subsystems this year. And then, we tend to name them after 80s pop culture like Gozer or McFly. So have a little
McFly.
fun with it.
I
Yeah.
love it. I don't know if there's a point to do anything if there's not a little bit of fun.
Yeah. I mean, especially in this industry, you're literally sending people to the moon, hopefully to set up a permanent base. You're putting people in flying taxis. There will eventually, in the not too distant future, be laser weapons mounted to planes and helicopters. Like it should be fun.
Yeah, it's going to be awesome. Hopefully.
I hope so. Yeah.
Got
We
to
can
keep
handle
those
it.
lasers in check.
That's right.
Slowly let those ones out. And this might not be your area of expertise, but um, kind of from inception, I know it's not on a napkin, it's probably some 3D CAD drawing, but like problem, product, all the way through R&D
Mhm.
to you sell it at some point.
Mhm.
What do you think that timeline is generally?
Yeah, it's longer than I'm used to. Sales cycles, like in enterprise software, which is kind of the longest that I was used to, is maybe about 12 to 18 months, and like that's a pretty short cycle for us. It's usually so you have really you have a couple of different parts to this. One is where you're doing technology validation. So we will do what's called digital engineering. So someone will come to us. It used to be that someone says, "Hey, here's a problem that we have," and you had to actually build it and test it to make sure it worked. Now we have computer simulations that we can use to say, "Okay, here are all the different points on a Pareto chart that you can pick," and we know that one of these will work because we've done the math and we've got the computer simulation to make it work. So we'll do digital modeling first and say, "Hey, we think this is viable," and then you get into prototyping. And in prototyping, you're saying, "Hey, we're going to validate the digital model with a physical prototype. We're going to test it. We're going to qualify it." And then for most programs that are significant, there's what's called a production back end to it. So the initial modeling, that's maybe going to take us like 3 months, right? To validate all of that. Prototyping could take 12 months, maybe longer, depending on lead times with parts that we need. And then production can be to get to there, it can be 5 or 6 years sometimes, but then you have booked revenue for 40 years.
Yeah.
So we're competing on a program right now. It's the largest military jet program in history, and if we win that program, we'll book revenue all the way to 2090. So there's payoff on the back end, but things do move slow.
2090, so you'll need to find your replacements at some point.
Right. Yeah. unless we figure something out, I won't be alive then. So
Right. Well, maybe you can live longer on the moon.
that's right.
Who
Yeah.
knows?
Yeah.
I'm sure they figure that one out already. Um, how do you guys go about recruiting talent? Because people here, by the way, if you're not familiar with St. George, you don't need to familiarize yourself. You can just leave it alone. But
Don't come.
it is obviously burgeoning and it's got its own great ecosystem, but it's not like um, a space hub, right? There are a
Mhm.
few of those. How do you guys recruit and retain talent?
Yeah. So I'll answer that question, but just first of all, on the point of St. George in Utah, part of why we brought the company here instead of keeping it in the Seattle area or maybe moving to LA or Texas was because we wanted to use it as like a center of gravity to bring engineering talent and like rev that up in Utah. So if you can get more companies like Intergalactic that do really well. So Northrop Grumman, as an example, has a massive program that they're running out of northern Utah, and I just saw a stat the other day that like I think 20% of GDP in Utah is tied to the aerospace industry. People
Yeah.
don't know that, right? So there are like heavy mechanical engineering and legitimate engineering operations happening here, but that's not happening in St. George. So Utah Tech University just got its engineering program up and running, and we're leaning in heavily to that to try to help them stand it up in a way that it produces graduates who are like ready to roll.
Yeah.
So we get a lot of graduates out of the of Utah State, out of the U. Even SUU has some good graduates, but we're never get right now. We can't get everything that we need because thermal systems design, for example, is a very specialized engineering discipline. So even before the pandemic, we leaned into hybrid and remote work.
Mhm.
So half our employees, we have about 65 employees right now. About half are in St. George. The rest are distributed, and wherever we find them, we're like, you can move to St. George. That's great, or you can stay where you are. So we got engineers in pretty much every time zone, including Hawaii. So all
Perfect.
over the world.
The sun never sets on your empire.
That's right.
That's lovely. Yeah, thermal engineering and all of the things we've described is not something you can just learn overnight
Yeah.
through Khan Academy, right?
Right. We would love to have that become like a thing in Utah where we have like this concentration of like great thermal engineers, and that's one of our goals. But that'll take some time.
Yeah. Well, I don't have a high enough functioning brain. If I did, this is where I'd be hanging out in the space industry because it's a new frontier and these don't happen too often.
Yeah.
A lot of adventures to be had. Well, very cool. Next time we do this, it'd be fun to do it at your company HQ. You
Yeah.
can
Come on
cover all
down.
the stuff and put us in the broom closet, but
We'll show you some cool stuff. There's some things we can show you for sure.
love it. Thank you so much, Brad, and congrats to you and your team. I'm sure there's a lot of pride in seeing what you guys are doing, and the cool thing is that you'll be able to see it in like real life
Yeah.
as like amazing engineering feats happen.
Yeah.
So thank you for taking the time.
Yeah. Appreciate it. Thank you.
Thanks.